Have you ever wondered how your phone counts your steps? You could probably do it, but how would a computer do it? Well, first, what data does your phone have? It should have acceleration magnitude at any given timestamp. What you can then do is use this data to manually find the shape of one step. Once you have this step pattern, you can apply this to new data by calculating the similarity between the pattern and your data at every timestamp. Timestamps with high similarity correspond to places in your data where a step likely occurred. But how is similarity actually calculated? What you can do is treat your step pattern as well as your actual data as functions, multiply them and integrate the result. This visual shows that when you do that, if the peaks and valleys line up, the product is mostly positive and the integral is positive. And when they don't line up, you get the opposite. Then you simply look at the similarity between your step pattern and your data at every timestamp, and that's what this shows. Not only can you see peaks where a step likely occurred, but you can hover over it to see the pattern overlaid on the data. This graph was actually the most difficult to implement, not for technical reasons but for pedagogical ones. The research paper is much more rigorous with this part, but we found that including more complexities did not help with gaining an intuitive understanding, and figuring out what to cut was difficult but ultimately made our project better. So now that we have the similarity between our step pattern and the real data at every possible timestamp, we just need to count the number of peaks, and that should be the number of steps. How can you count the number of peaks? Well, here's one easy algorithm. You can say that a peak is any point that is a maximum within some interval of itself. If you take a wider interval, you get less peaks, and if you get a narrow interval, you get more peaks. And that's what this visual shows very clearly. If we apply this peak counting algorithm to our similarity data, these are the peaks that we get. For the interval width, I simply use the width of one step pattern, which is exactly 1 second. This plot shows the peaks in the similarity data as well as the steps they correspond to in the acceleration data. Note that the steps line up end to end, which makes sense for someone walking continuously. Our visualizations are valuable because they fill in the gaps. They explain things in an intuitive way that a research paper aimed at a more narrow audience might gloss over. If you get one takeaway from our project, it should be that step counting really can be as easy as saying, does this look like a step or not? The hard part is turning that intuition to something that a computer can do, and that applies to many things in data science, not just step counting.